Okay, 2.6 linear inequalities. You remember this is just linear equations and we shade, right? You dash the line or a solid line and then shade. Okay, we're having difficulties today. Let's just do one. Systems of linear inequalities. Okay, so let's look at we'll just throw that up there. X is greater than or equal to 6. We're going to have to scale this to fit it on our grid. So what's the y-intercept of the first one? 10. What's the slope? Thank you, Jared. You subtract the x over. Right, so you get, if you do that, you get y is greater than negative x plus 10. Okay, if you need to rewrite it. That one is a vertical line at 6. So what do we need to scale to here? 5s? 2s? 10s? 2 is going to make it really funny. Let's do 5s. And on this one we can do, let's do 5s as well. So I'm going to do that one in green. So go ahead and graph that. Is it dashed or solid? Okay. And where do I shade?
Why is your line the opposite way?
Oh gosh, you betcha. Nice catch. Okay, let us do this correctly.
And you should do it at 10 instead of 5.
Okay, and then a shade above. I'm just going to put an arrow because we're going to have to shade two lines together. So. Oh my gosh. Would somebody else like to do this today?
Yeah, I was like, you should graph it at 10 instead of 5.
You did say that. I thought you meant scale. Okay, let's try this again. Am I correct this time?
Maybe. Okay. There you go.
A lot tired, actually. No, he didn't. That sickness a lot of you had really badly, he didn't get very bad, so it was only a day. I'm just tired. And then x is greater than or equal to 6 is a solid line at 6, right? Which way do I shade? To the right. Okay, so the trick with these is shading where both of them intersect. So if this is the red, whoop, wrong color, and this is the green. Where am I going to shade with the double color? Right here. So that, on your papers, if you don't want to put the red and the green shading, don't. All you need is the double shaded. Okay. What is, here's a question. What's the intersection point of those two lines? We know the x value is 6, right? Because of this.
Yeah. Yeah.
So how, the y value? 4. Okay. So again, caution you, you can look at it on the graph and it would be approximate. But only exact way to do it is to take the 6, plug it in for x, and solve. Okay. You will have to be able to use that skill for 2.7. Linear programming. You hated it, actually. Okay. Are we good there? Okay. No answers. That's great. All right. So that is the easier part of this. I'm confident you can take care of that. Here's where it gets a little more difficult. This is how it's going to be worded. This is why I'm showing it to you. The wording. Yes.
Wait, have you already been with us? Is it gonna make you cry? Did we watch it last year?
I think you're gone.
Okay.
A lot of people were gone.
Are we still bad? Was it the old man like talking about it? Is that what it is? Like Brian.
And wasn't and then they do a show on it. Well, we got scheduled on for 3 days. we watch that and then so we go back.
These can get to be big problems. You just have to kind of go step by step.
We don't got that.
Okay, this one we don't graph because it's our maximum minimum analysis equation. Okay, we graph these four as a system of inequalities. Aye. Yeah, I know. Get with the program today. I'm going to put that one in black. It is
Negative x, y is
the y-intercept is. Oh, let's we got to scale this beast too.
y is less than.
I'm going to go by twos. Okay, so the y-intercept of that black one is 3, and the slope is negative 1/4 for the first one. And it's a solid line.
Down 1/4.
Subtract the x over. That's negative 1. Divide by 4. Okay. And we're shading that direction. Subtract x. Divide by 4. You get y is less than or equal to negative 1/4 x plus 3. 3, and then down 1/4. Okay. If you can graph all those, have at it. I'm not going to hold you back. All right. This one is in green.
Negative 2 or 3 over 2 and 2. I mean 3.
Now, keep in mind you're dividing by a negative here. There's your sign. You got to flip it. Okay. You
And
gotta
that
flip
first one is a negative. That's 3x. That's negative.
it. No, because you minus 3x and then divide by negative 2. You're so negative 3 up 3 over 2, and we're shading that direction. Is that right? Oops. Oh well.
The next one.
Yeah. This one's going to be goopy because I wrote down the wrong equation. Let's just roll with it, I guess. Do you want me to change it to what the book says?
Sure.
Because it's better.
I don't want to.
All you got to do here, don't just calm down. I know. He is.
Uproar.
Uproar. Uprising. Anarchy. Down with the capital. All it is a negative 6.
Which one? Oh.
But it changes it to a positive and a negative. Nope. Sorry. So all it does is change the y-intercept to a positive 3. It's really not, but. Sorry, I'm having a rough day apparently. What's new, right?
Okay.
Thanks. Okay. This one. Right. And then the last one. And then so the shaded region is actually in here. Okay, so that's the graph. Okay, that's the graph. Just looking at it, do you think any quadrilateral guesses? Are there any parallel sides? Probably not. Okay, so it's not. There's only one option if there are any parallel sides: a kite or a quadrilateral. It might be a kite. We're not going to worry about it, but we have to figure out those 4 intersection points. Okay. This one here, the top one, should be easy. Why? Why should this top one be easy? Yeah, it's the y-intercept of both of these. Okay, so we have 0, 3 because of the y-intercepts. They're the same spot. Okay. Now, what about this one here?
-2.
4, 2 is a reasonable guess, right? This one. The top right.
Mine's at like 2. Or yeah, 4, 2.
4, 2 is a reasonable guess, but is that exact?
No.
When you're running a business, you want to be exact, right? We're going to get to business applications of this, so that's why I say that. So what 2 equations are those? The black one and the red one, or the orange one? So we need to solve this system. And solve that system. Times 3. You can do -3 if you want. And that's going to be 36. Oh, I am on a roll today. That's going to be 12. Subtract. So 0, 12 minus -4 is 16y, and
Why is it -4? Isn't it y?
gosh, 12 minus -1, y, yeah, it's 1y, 13, yeah. So y is 2, which means x is 4.
Yeah, we were right.
Do I need to show you the rest of them? Is there a potential of up to 4 systems in this that you have to solve? In the interest of time, I just want to give you the answers and show you the min-max calculation. Okay, so the bottom point here is 2, -4. And the other point is -2, 0. Right? Okay, we're almost done here. Okay, so that's our min-max equation. Okay, if you're running a business, this is going to be tied to cost of profit. Okay, so you want to maximize your profit. That's what 2.7 is. We'll do that next week. So basically we're giving you this equation. If you're running your own business, you have to actually have to write it. You have to do it for each of those points. So 0, 3. Gives us an output of -1. Right, so 4, 2. 4 minus 2 plus 2 is 4. 2 negative 4. 2 plus 4 plus 2, which is 8. And -2, 0. -2 minus 0 minus 2 is -4. What's the max? This is the max. And the minimum is -4. Okay. At those 2 points. So if you're running a business, making dollhouses, and you have 2 styles of dollhouses, you'd make of one dollhouse and 4 of the other, and you'd maximize your profit or whatever. So,
About one is like,
I,
yeah, the last one. That would equal 0.
oh, good call. Okay, so it's not the minimum then.
-1.
So this is 0. That's the minimum. I should have let this one go, huh? Let someone else teach it? Tuesday we're starting NWEA testing, so
Hey,
this is due Tuesday, you're handing it in to me. We're not grading it as a class. Make sure it's spick and spam.
try to copy that, huh?